All right, Unit 2, Assessment. Question 1 says, the table represents the area, y square units of a square with side length of x units. So we have a square, so let's draw a square. So we're going to start by drawing. So we draw the square, and you know that the area, so we're talking about the number inside, is going to be y square units, and it is telling you that the side is going to be x. Now, since it's a square, it's going to be x. Okay, we're just drawing a visual representation. Now, the question says, does the table represent a linear function? There are two ways to approach this. So we're looking for, is it a linear function? To know if it's a linear function, we need a couple things. We can either get the equation. You can find another way to do it is finding the rate. Another way to do this is finding the slope. There's a couple things that you can do. All right. Now we know that the formula for this area will be y equals x times x, which is the same thing as saying x to the second power. So you could write that this is not a linear function because the equation is x to the second power, which is not in the form y equals mx plus b. So if you wrote that explanation, that would give you 2 points. Now, another way to approach the same problem is finding the unit rate or the rate of change or the slope of the table. To do that, you can actually use the slope formula, but since the table is already given to you, we're going to go back to something that you should have learned in 7th grade, which is finding the rate of the x values and then the y values. So we see how much is increasing by. So from 0 to 1, it's increasing by 1. From 1 to 2, it's increasing by 1. And from 2 to 3, it's increasing by 1. Now, on the y values, you have 0 to 1, and that's increasing by 1. And then you do 1 to 4, and that's actually increasing by 3. And from 4 to 9, it's increasing by 5. Since these numbers are constant, but these are not constant, we say that it doesn't have a unit rate. It doesn't have a constant rate of change. So let's write that down. It is not linear. And right here is supposed to be, is not a linear function. Okay, it's not a linear function because it doesn't have a constant rate of change. Problem number 2 says, Jerome and Brandon are saving money for a trip. The table shows the amount of money Jerome saves each month. The graph shows Brandon's savings. So we are connecting Jerome to the table and Brandon to the graph. To be able to compare them to figure out which one is more expensive, you need to consider a couple things. You need to write the slope and the y-intercept. Okay, so we're going to start with Jerome. So we have 0 is going to be 75. So on month 0, when he began, he already had $75 saved up. And now, on month 1, he has 150. On month 2, he has 225. On month 3, he has 300. So we see that the numbers are increasing by 1 on this side, on your X values. Now, the Y values, they are increasing by 75. 75 plus 75 gives you 150. 150 plus 75 gives you 225. 225 plus 75 gives you 300, and the pattern continues. So it keeps increasing by 75. So your rate of change, your M, your slope, is going to be 75. Now, to find the initial value, the only thing that you need to pay attention to is that 0. At 0, he had 75. So that's going to be your initial value. So B is going to be equal to 75 too. Now, you could also use the slope formula to find it. You just choose any 2 points that you would like. For the next one, we have the graph, and we're going to pay attention to the initial value. The initial value is right here. That is the point 0, 0. That means that at month 0, he had no money saved up. So that's going to be our first number. Our B for Brandon is going to be 0. Now we need to find the slope. Okay? Now if you go to number 1, you see that number is not clear where it is. If you go to number 2, we know that it's somewhere between 100 and 150. We go to 3, it's between 150 and 200. So we don't actually have precise numbers all the way to 5. When you get to 5 months is actually $300. So that's what we're going to use. We're going to use that point to use the slope formula. So our first point is 0, 0. Our second point is going to be 5 months and $300 saved up. We're going to repeat our process to find the slope. So we're going to start by labeling. So we're going to write x1, y1, x2, y2, and we're going to write the formula. M equals y2 minus y1 divided by x2 minus x1. We're going to plug in the numbers. We know that y2 is going to be 300. So we write 300 minus 0, and then you're going to do 5 minus 0, and now you're going to get 300 divided by 5. That will be equal to 60. Okay, so going back up, we know that the slope for this problem is going to be M equals 60. Now let's read each statement. It says, they save the same amount of money each month. Now, Jerome saves 75 and Brandon saves 60. That's not correct. So we're going to cross that one out. The next one tells you the rate of change of Brandon's saving is less than Jerome's. 60 is less than 75. So that one is true. Okay, we're going to keep reading the statements. It says the initial value of Jerome's savings is less than Brandon's. The initial value for Jerome was 75, for Brandon was 0. That's not true. And the last one says, after 5 months, Brandon has saved more money than Jerome. At 5 months, he has 300. At 5 months, Jerome has 450. So that's incorrect. But you need to read every single statement to make sure that the one you chose is correct. Question number 3 says, write an equation that is not linear. Not linear. So we're going to be paying attention to an equation that is not a linear function. And then it tells you to explain why it's not linear. Okay? So we actually need an equation. That means that you're going to have y equals some x. Okay? Now, we're going to start a little backwards so you can understand the question. So, a linear function has an equation that looks like y equals mx plus b. Now, if there's no initial value, your equation may look like y equals mx. Because there's no initial value, or your initial value is 0. So, an equation that is not linear needs to be different than those. So if we already have that a linear function has an equation that looks like y equals mx plus b, or y equals mx, then y equals x to the second power is not linear. Okay? It's not linear because it doesn't look like y equals mx plus b or y equals mx. It has an exponent of 2. In this case, we don't have another exponent. This one has an exponent. That is the easiest way to do this question. Just give me something that is not linear and explain why it's not linear. This question is worth 2 points. 1 for giving the linear function and 1 for the explanation. Now, if you don't have the explanation, you won't get credit at all. Keep in mind that there's an infinite number of equations that you can write. Another example of that will be y equals 1 over x. Another example of that will be y equals x to the 15th power plus 1. So we have a large number of equations that you can write. The easiest thing you can do is just write y equals x to a different power, and that's it. Now, for number 4, we are going to be dealing with information from lesson 10, which is qualitative graphs. Now, this one is talking about distance from home. Okay, so you're figuring out the distance away from your home. Let's read each statement and determine whether it's true or false. The first says, section 1 shows Eric moving away from home at a steady pace. Now, this is section 1 in Roman numerals. So this is the distance from home. That means that at 0, he's actually home. The point 0, 0 right here, let's label it. We're going to put, this point is going to be home. So if the y value is 0, that means that he's going to be home. So he's at home and he's going away from home at a steady speed. That's true. The next statement says sections 2 and 4 show Eric at a constant distance from home. So again, we're paying attention to section 2, 4 in constant distance. So if we go to section 2, there's no change. There's no slope. So that means that he was at a constant distance. And now, section 4, same thing. Whenever you see the horizontal line, means that he's not moving. So, that is true. The next part says section 3 shows Eric moving away from home at the same pace when he left home in the morning. So, we need to highlight that he's moving away from home. But this section shows that he's going down. That means that he's actually getting a little bit closer home than getting away from home. So that statement is false. And the last statement says section 5 shows Eric moving towards home at a slower pace than when he left home in the morning. So we're talking about him moving towards a home slower. If you look at the inclination, the steepness of the line, this is a little more horizontal. It's not as steep as the morning. Okay? Maybe he's going to work and he woke up late, so he needs to go really, really fast. Now, when he's going back home, maybe he hit traffic. That's why he's taking a little longer. But you see, it took him a little longer to cover the same distance. So this statement is true. Number 5 says, a county park charges a $175 fee to rent a pavilion plus $20 per guest. Now, so we have $175 fee and you have $20 per guest. You have $175 that will be flat. It doesn't change. You invite 0 guests, you're paying $175 for the rental. You invite 2 guests, again, you're only going to be paying $175 for that rental plus now the guests. So the fee, that flat fee, is going to be your B, your initial value. It's your initial value because it doesn't matter how many guesses you're taking. You still have to pay 175, and that's flat. Now, here is where it changes. It's $20 per guess. So M is going to be your rate of change. So if you invite 0 guests, that number is going to be 0. But if you invite 1 guest, now you're paying $20 for that guest. If you invite 2, now you're going to be paying $40 plus the fee. If you invite 3, you're going to be paying $60 plus the fee, and so on. Now, it tells you to write an equation for this function. So we're going to write the equation in the form y equals mx plus b. We already labeled what our m and our b was. So we know the b is going to be 175, and your m is going to be 20. And that will be your answer for part A. And that part is worth 1 point. Now, part B says, what do the slope and y-intercept represent? So the only thing that you need to do is use the information they're giving you and put it into context. So the slope is the same thing as the rate of change, and you're going to put 20 per guess. Okay, so it's going to tell you slope is the rate per guess and the y-intercept is the rental fee. And that'll be all for you to get the full point on that question. To change the temperature in Fahrenheit to a temperature in degrees Celsius, the equation C equals 5/9 plus negative 160 over 9 can be used. Now, this is something that you are going to use when you go to chemistry class. That is actually the equation. Now, part A says, explain how you know the equations represent a linear function. So you're going to be checking why can we say that it represents a linear function. In this case, we need to label what our m and what our b is. And the easiest way to do it is to just write it underneath the equation. So we write y equals (5/9x plus negative 160 over 9. Now that we have that, that looks more like a linear equation, and we can identify the parts. We can say m is equal to 5/9, so it has a constant rate of change. B is equal to negative 160 over 9. So it has a rate of change. It has an initial value. So those are two things that we have. And the main part is that it's written in the form y equals mx plus b. And that'll be all. Now, part B says, what are the slopes and y-intercept of these functions? What do they represent in the context of the situation? So, we actually already did that part, so we just need to copy that information. M is 5/9, and B is going to be negative 160/9. Explanation is going to be a little bit challenging though. Okay, we are going to create a table a very, very short table. So we're going to have so we're going to create a very short table where we have C and F on one side. And this is going to help you understand what's going on and try to make sense of it. If Celsius is 0, your initial value will be negative 160/9. Okay? So that means that the y-intercept means that when Celsius is 0, Fahrenheit will be negative 160/9. And the slope is the increase in temperature. What's up? Problem number 7 says, which equations represent a linear function? And then says, choose all that apply. So the first thing is we're going to highlight the word linear and function. And then keep that in mind that whenever you see all that apply, that means that you have more than one answer. So, the equation of a linear function is going to look like y equals mx plus b. That means that there's no exponent right there. You just have to have a slope and a y-intercept. Or just the slope or just the y-intercept. Now, let's go one by one. So A is going to be equal, it says y equals x times x. Another way to write x times x is x to the second power. Now, y equals x to the second power is not a linear function because it has that exponent. If it has an exponent, it's not a linear function. So we're going to cross this one out. The next one, B. Y equals 2x. In this case, the 2 is going to be your slope. And we could actually say that the y-intercept in this case is 0 because there's nothing right here. So we could actually put a 0 here and say, okay, that one works. It's in the form y equals mx. or mx plus b. The next one, C, one more time. You have y equals 0.25x, so this is going to be your slope, and this one will be your y-intercept. Okay, so that's also a linear function. Okay. He needs to have the study guide. He already has the study guide.
Oh, he does?
So he should be taking notes. How many of you guys had B as your answer? C as your answer? E as your answer? Okay, so we got a decent chunk. So all those things that you're covering with Ms. Guerrero supposed to make this class easier. If you're not doing her work, guess what happened to my class? It gets harder. This is the time you highlight, right? Melanie, where's your highlighter? Hmm? Mister. Another coffee. Everybody finish highlighting? Okay. Hold on. There we go. To make... Oh, it's recording. So you have inputs and outputs. We have inputs and outputs. Remember, your inputs are going to be your x values. Your outputs are going to be your y values. The only thing you need to do is look at the points. All the x's go on one side and the y's go on the other. So we're going to start with the first number, -3 and 0, and you make a line. The next number is -2 and -3, and you make a line. 0 and 0, and you make a line. 1 and 5, and you make a line. And the last one is going to be 2 and 5, and you make that line. Another way to graph this into a map is put the input, the output, and we're going to do -3 goes to 0, we connect that. The next one, -2 goes to -3, you connect those two. Now the next one is 0. Since we already have a 0 right here, we can actually draw a line to connect those two. The next one is 1 and 5, we make that line. And the last number is going to be 2 and 5, but since we already have a 5 right here, we can make that connection. If you draw the diagram like that, either or the left one or the right one, you will get full credit for part A. Now, the next part says, does the diagram represent a function? Okay, and then you need to explain. So we're going to highlight that part. Does the diagram represent a function? We're going to highlight function and the fact that we need to explain. To know if it represents a function, the only thing you need to do is see if your inputs repeat. So right here, we have -3 goes to 0, -2 goes to -3, 0 to 0, 1 to 5, 2 to 5. Your inputs only have one output. That means that it's a function. So we're going to write, it is a function because each input has only one output. Question number 9 comes from lesson 10 when we're dealing with qualitative graphs. And these are graphs that don't have necessarily numbers, but it gives you the overall idea. Mr. Makarsky drives to his office one morning. All right, so now that is the first thing that we need. So he's driving to his office. After he leaves his house, so he starts at his house and then he's going to drive at a constant speed until he reaches the office. So that means that he's going to drive without stopping all the way to the office. After work, he drives home at a constant speed. Okay, so he drives home at a constant speed and then he reaches a stoplight. So at that point, he's going to stop. He says he waits at the stoplight and then he continues to drive at the same speed until he gets home. Now, if you're paying attention to A, very, very important to read the graph to understand what's going on. So it says distance from the office. Okay, so how far away he's from the office. That is our point. Now, the x-axis, and we're going to label that part, is going to be office. And then the y-axis is going to be distance. Now, for A, at the beginning, it seems like he's already at the office. And that's not the case unless he slept in the office, but that's not what the problem is telling you. It's telling you that he started at his house. So that means that from his house to the office, there's going to be some distance. So this one is not the case because this will mean that he slept in the office. Now, let's look at B. So B tells you that there's a distance right here. So this initial point should be his home. Now the problem tells you that he drove from home to the office, but it tells you that he did it at a constant speed. Constant speed without stopping, but right here you can tell that there was a stop. Something happened right there, so he stopped. It may be a red light. If you read the problem, it tells you that he drove from home to the office without stopping, so this cannot be your answer. Let's go to C. C has the same mistake telling you that he slept in the office. Right? Because he seems like he's from the office, he drives away from the office, spends time there, and then goes back to the office, which makes no sense. So that's not the answer. And then if we look at D, he starts at home and he drives at a constant speed, so that works. So after some time in the office, he didn't move. He drives home, stops at the light, and now continues to go home. Okay, so that will be your answer. Your answer is D. Number 10 tells you which table represents a function. And it tells you choose all that apply. So you're going to have multiple answers. We're going to start by finding the constant rate of change, if there's one. And we're also going to be paying attention to the input and output values. Okay, so the main point here is a function. We're paying attention to a function. That means that the input values can only have one output. So for A, X gives you 0 for 1, and then you have 1 that also gives you 2. So if you input the same number, you're getting 2 different outputs, and that cannot be possible. So A is not a function, and your explanation will be because X equal 1 has 2 different outputs. Now let's check B. 1 goes to 3, 2 goes to 6, 3 goes to 15, 4 goes to 9, and 5 goes to 3. The input values are only going to one precise output. So this is going to be a function. So B, it's a function. Each input has only one output, and that's it. For C, one more time, we're going to be paying attention to the inputs going to one output only. We have 1 goes to 4, 2 goes to 3, 3 goes to 3, now 3 goes to 2, and 4 goes to 1. Now, right here is the issue. Think about a vending machine. If you press the same button twice, so if you press 3 and 3, you're getting 2 different items, 2 different outputs, and that's a broken machine. It's not something that is going to work, so that's not a function. And the logic will be 3 has 2 different outputs. Let's go to the next one. We have 1 goes to -2, 2 goes to -1, 3 goes to 2, 4 goes to -1, and 5 goes to -2. Now, the X values don't repeat, but you see that the Y values do repeat. You have a -1 here and a -1 here. Now, the Y values, they can all repeat. That won't change a thing. So the only ones that we care about is that your X values don't repeat. So this is going to be a function because the X values have only one output. And the last one, E. 1 goes to 3, 2 goes to -4, 3 goes to 0, 4 goes to 5, and 5 goes to -8. Once again, your X values have only one Y value. that means that it's a function.